Hey there, CC friends. This is going to be pages 5 through 8 of the division for Math Map. Um, Again, this is this is a lot of this I'm trying to make applicable to if you're doing the printable versions or you have a child in challenge with the complex. Naturally, the complex is going to be the one that has the most difficult concepts, but I'll try to relate them back to things you might see in the actual curriculum as well. Um, as you're working with your child, if you're doing the fractions, the digits, or the naturals, just always remember that it's still under development, and that it's one of the reasons it's available online, because I keep having to remind myself there's just certain times where things might seem a little too basic, or too advanced, and I keep reminding myself, we're not going to see the finished product until next year. So with that said, let's look at page 5 for the complex. Has a couple concepts that I just thought would be good to kind of make clear. And one of them is this concept of if we have a fraction. So let's just say 2 plus I over, this is actually coming out of the book on page 5. Now, if we have 2 plus I over 11, this is something I see that, for a lot of students in higher levels, it's a difficult concept to remember. But this is the same as 2 over 11 plus I over 11. It might seem really basic, but the only reason I'm saying it right now is because they're illustrating it and they're having you follow a pattern in this one example. And it is relating to the distributive property, which we have a memory work piece on for CC. But why would it be? Because we know that if we multiply a fraction by a fraction or by a whole number, okay? So I'm going to kind of write it like that. See how I put it up high? Well, that would just be a whole number, but I always teach students that any whole number is just over 1. Oh, little guy, it's okay. Any whole number is always over 1 because we can divide anything by 1 in itself, and it makes fractions just less intimidating and easier to work with. Truly, actually, let's do it like this because then it makes even more sense. So each one of those pieces is over 1. And when we distribute, when we do a fraction, it's just the top times the top, bottom times the bottom. So this would be 2 over 11, because 1 times 2 is 2, 11 times 1 is 11, and then plus I over 11. So we can see that. But then the process with common denominators that we've learned is when we add and subtract, the denominator does not change. So this just becomes 2 plus I over 11. And it may be useful at times to write it either of those two ways. When we're dealing with the complex number system, generally you're going to want this, the first version, because I can't add 2 and I. And if you've watched my video about I, and I explained a little about the complex number system, we eventually want to be able to see it as the real part and the imaginary part. So in especially the ones with I, that's more useful, but you'll also see that there's not just I's in that one example if you're using the complex. So anyway, that was just a quick little, wanted to mention it. And then erase this, and we're gonna do a little bit with division by 0 because I know it came up early on, and we're just gonna talk about it for a second. So if I have a over 0, and I say it's undefined, why? And then I say, oh, but it also equals infinity. So how does that make sense? So it's undefined in terms of finite numbers, meaning I can't ever talk about it unless I talk about infinity. So isn't that kind of cool? Because we always, for when we talk about the concepts of God, some of the doctrines of God don't make sense unless we're accepting the fact that there's an infinite God, even though as finite beings we can't understand that. The understand of no end is easier to understand than no beginning. There's like, how do we explain the Trinity? There is one God, there's three persons. It's yes, that's how we've heard it, and it might be easy to accept, but if you really think about it, that's very difficult. Or Jesus was not half God and half man, he was all God and all man. So in that, we have these doctrines of God that we have to accept certain principles outside of our finite level of understanding. So that's the same thing we have to do with math, but we can still talk about it and it can still make pretty good sense. So a over zero, what happens if I have a fraction? Let's just pick easy numbers. Let's say I have 1 over 2. I know it's a half. If I have 1 over 4, that's 1/4. So it's getting smaller and smaller and smaller. If I have 1/100th, hopefully we know that, we're slowly getting to be a smaller and smaller and smaller number. So if I have 1 over a million, it's even smaller than 1 over 100. So they're getting smaller and smaller and smaller and smaller. Now let's look at the concept of what we call the reciprocal, which is actually a little bit on the next page, and I was going to illustrate anyway. So the reciprocal property says if I have 1 over 1/2, so if I divide a fraction by a fraction, it is the same as if I multiply by the reciprocal. Reciprocal is a big word and it just means flip it. Okay, so probably many of you remember this, or maybe now you're remembering and didn't before. This is a concept that's taught in the later elementary years. So with that, whenever we divide by a fraction, we multiply by the reciprocal. So this would equal 2. Okay, if I had 1 over 100, this is the same as 1 times 100 over 1, or 100. Do you see how it's getting bigger? So it's getting bigger and bigger and bigger. Let's say I did, put it up here, 1 over 1 million is equal to 1 million. Okay? It's getting bigger and bigger and bigger and bigger. So, as that number on the bottom, this guy, gets smaller and smaller, because we just talked about fractions and how they work, the actual value is getting bigger and bigger. So, what would happen if this number here got so small that it approached 0? I made it so, 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 so small that somehow I can make it so small that it will reach 0, but I can't really do that, right? But so as I'm doing that, what's happening is I'm thinking about the denominator of that little fraction I'm dividing by is getting bigger and bigger and bigger. So if that number somehow possibly reached infinity, then this would be 0, and I would have division by 0. But we see by the reciprocal property then that this would equal infinity, the biggest number possible that we can't reach. And that is why in finite numbers and most math curriculums, up until we reach discussion of infinite topics, which is generally around pre-calculus, that many students in high school nowadays don't even reach, we just say undefined. If you plug it in the calculator, it says undefined. But it's undefined because we can no longer talk about it in finite numbers. However, all of upper levels of math are based around infinite concepts that relate. That's what calculus is all about. And we get into infinity. So that's just a fun little discussion of the why. All right, we'll talk more about that in the future. We already talked about the reciprocal property. So one cool thing is these factorials that I talked about in another video have returned. That's where you see the little exclamation mark. So your factorials can be fun, especially in illustrating how to cancel factors. So there's this one example where we have 6 factorial over 3 factorial. And I like how they're even throwing this in the fractions and the naturals just in like little forms so they learn what this is. This is 6 times 5 times 4 times 3 times 2 times 1. It's every single number of the factorial itself and that or whatever, 6 factorial is 6 and then times every number that comes before. 3 factorial is 3 times 2 times 1. So we talked about this when they're separated by multiplication symbol, we can cancel little pairs. So we cancel all the little pairs. We don't have to worry about the ones, but I think for kids it's really good for them to tangibly see that, even though they know 1 times 1 is, or any number times 1 is itself, any number divided by 1 is itself. So we end up with 6 times 5 times 4. And then, especially for your younger kids or even your older kids, remember this is a good time to work on division so they could do their skip counting. 6, 12, 18, 24, 30. And they get to 30 and we have 30, but then we have a 4. So 30 is an easy number because 3 times 4 is 12, and then you add the 0. But if it's another number, let them practice that, like those longer multiplication problems. Because I'm sure some of you are feeling like, is my kid going to have mastery of the things they need to know? And remember, this is work on the things that you know your child needs to work on. So if they were doing Saxon math or another math, all the way up until now, have them work on some of those concepts that you knew were a struggle or maybe you haven't covered yet. Take that extra time and then continue working through the map for, cool new knowledge, seeing new things. But there's lots of opportunity still to work on areas where they may need to work on. And we're going to try to keep this video at 10 minutes. We're over 10 minutes already. So I'm just going to look here and see. Is there anything else? I think that was pretty much what I had highlighted. And my next video will cover pages 9 through 12. So thank you for joining us. Have a great day.